Hello, algebra students. Welcome to lesson 5.5, more about formulas, starting on page 119 in your textbook going through page 123. If you recall, a formula looks something like this. For example, the formula of a perimeter is P equals 2 times x plus y, or volume of a square base would be volume equals x squared times height. Formulas are just basically those types of equations or setups actually that always work for a given situation. Therefore, you have a formula where you plug in numbers, and that's what we're going to be doing today. We're going to be working with formulas, plugging in different numbers to find solutions. So we're going to begin on page 120 with try at 12, where we have the formula of motion, for motion of an object. So basically the setup is S equals UT plus half of AT squared. If you're interested, U in the formula stands for the initial velocity or speed. A would be the acceleration, so how it picks up speed. T is the time of the motion, and S is the displacement. So all of that working together gives you the formula for motion of an object, in case you ever need to do that. So the first situation is you always copy the formula. In A, the situation tells us that S, we want to find the value of S. So S is unknown when A equals 10. So in the A spot, I put the 10. And it says U is 20, so wherever U is, that's where I put 20. And T is 3, and T occurs twice in the formula, so it's like UT, so 20 times 3, and then at the end it's T squared. So I just plug my numbers in. The half is already there. I'm solving for S. So I end up with 20 times 3 plus half of 10 times 3 squared. So, of course, 20 times 3 is 60. Half of 10 is 5. And 3 squared is 9. I add this part to that part, so 60 plus 5 times 9, which is 45. My answer is 105. So that was pretty straightforward. If I went too fast, please rewind and watch again. B, use that same formula for motion of an object, and I have different numbers to plug in. This time they want us to find the value of U when A is 6. So 6 goes half times 6, so half of 6, which will be 3. And S is 203, so that's what the whole thing's going to equal. And T is going to be worth 7. So in the T position, UT would be U7, and at the end I have 7 squared, which of course is 49. Just to line things up nicer, I flipped my 7 and U, because U times 7 is really 7U. So I end up with 203 equals 7U plus, like I said before, half of 6 is 3, and 7 squared is 49, so 3 times 49 ends up being 147. I just recopied that. I bring 147 over by subtracting. 203 minus 147 is 56 equals 7U. I'm solving for U again, so I divide through by 7 after I flip it because I like my U on my left. And when I divide, I end up with U equals 8. Okay, moving on to try it 13. Now our formula is this. T equals U plus V over U minus V. So A asks us to find the value of T when U is 20 and V is 15. So T is going to be 20 plus 15, which is 35, over 20 minus 15, which is 5. And of course, 35 divided by 5 is 7. So therefore, T is worth 7. So far, so good. In part B, starting on page 122, oops, I forgot letter B. Sorry, back to page 121. So sorry. Same formula. Same formula. And now we are going to find the value of v when u is 18 and t is 5. So 5 is going to equal 18 plus v over 18 minus v. So in this case, I'm going to do my cross multiplying like I did last lesson, where I'm going to have 5 times 18 minus v equals 18 plus v. I distribute my 5 to the 18 and negative v, which gives me 90 minus 5v equals 18 plus v. And I'm going to bring my 18 over by subtracting, so 90 minus 18 is 72. I'm going to take my negative 5v and take it to the other side, so that's positive 5v plus v gives me 6v. I flip them because I like my letters on the left, so 6v equals 72. I divide through by 6, v equals 12. There we go. Now we get to move on to try it 14. Part B. Now this is in a situation where sometimes they want you to realign the entire formula and write it, express it in a different way. So in try it 14, they give us this formula, but in part A, they want us to express u as the subject of the formula. That means instead of s equals, we want to get it so it's going to be u equals something. Okay, you might wonder, why do you even want to do that? Because you can just plug in numbers, but evidently it is sometimes advantageous to do this if the numbers are wonky, and sometimes it's just easier to do it this way. So proceeding, I'm looking at that. I'm remembering I need to get u as the subject. So my objective is to get u onto this other side, but I have to do it in stages. The first thing I want to do is take this whole unit right here, that positive half at squared. I'm going to bring it over to the other side by subtracting the whole thing. So that's what I do. S minus half at squared equals ut. Now at this point, I'm going to flip these things around because I like the u on the left, so ut is going to equal s minus half at squared. You see where I'm going? I'm going to get u by itself by dividing through by t, but this is going to look kind of wonky. So I have the s part divided by t minus this whole part divided by t, and I'm going to end up with u equaling s divided by t, st minus, I'm going to end up in this situation where I can actually eliminate that denominator t because of this t squared. So remember, when you divide t's, you subtract the exponents. So this is going to go away, and I'm just left with one of the t's. So I end up with half at. So u equals s over t minus half of at. And there you have that. Again, sometimes it's just advantageous to do this. Practically speaking, I would just always plug in the numbers and see how it goes. If it's really hard to work, then I would realign the equation. But it's interesting to know that you can do that. Anyway, letter B then, now that we've realigned the equation, just using that, now we're going to find the value of u when a is worth 6. So a in this position is 6. And s is worth 203, which is right here. And t is 7. Okay, so these are the same numbers that we used earlier, but now I'm solving for u. So let's go ahead and do that. So I have 203 divided by 7 is 29, minus half of 6 is 3 times 7, which is 21. 29 minus 21, u equals 8. There you go. So sometimes they have you realign it and plug in numbers, and it works. Now, if you kept it in the original equation, it would also work, but sometimes this is a little bit easier. Okay, let's go on. Try it, number 15. Here they just want us to take the given formula, which is S equals K times 1 plus R over 1 minus R, and we are going to make R the subject of the formula, where R is not equal to 1. Okay, the first thing I got to do is do the cross multiplying to get rid of this denominator. So I'm going to end up with S times 1 minus R equals K times 1 minus R. Now I'm going to distribute the S on the left and K on the right. So S times 1 is S minus S times R equals K times 1 is K plus K times R. Okay, so far so good. Now what I want to do is bring my K over here and my SR over there. So I'm going to have my single letters on one side and my double letters on the other side. So I'm going to minus K. So I have S minus K. But here I'm going to add the SR to the other side. So since it's positive, they started off with SR, which is fine. SR plus KR. All right, so they're both positive. Doesn't really matter the order, except S minus K. Now, right here, I'm going to factor the R out of those things. So R times S plus K. Just because when I do that, I am going to notice that, again, I'm going to flip it over because I'm working for R. I'm isolating R. So I'm just going to flip these two sides. So I did that. I had R times S plus K equals S minus K. I want to get R by itself, so I'm going to divide through by S plus K on each side. This eliminates. I'm left with R equals S minus K over S plus K. And there you have that one. They don't have any numbers for us to plug in to this situation, but there you go. You can mess with numbers just like you do with, or mess with letters like you do with numbers. Now, they saved the really complicated one, of course, for last, and they throw in some square roots. So in this equation, they want us to work it such that H alone, not H squared, but H becomes the subject of the formula. So I wrote a couple hints here. The first thing you want to do is get rid of this square root sign. And you do that by squaring everything. So we're going to have S squared equals pi squared, R squared. And because I'm squaring this whole thing, I'm just left with what's in the inside. But what's in the inside is a unit. So it's going to be times H squared plus R squared. So they got to stay together. That's why I threw in the parentheses. Now I'm going to distribute the pi squared R squared to each of these components. So we have S squared over here equals pi squared R squared times H squared plus pi squared times, now look at here, R squared times R squared. I have the same letter. That means I add my exponents, so it's R to the fourth, because I'm just adding those two. So there we go. Or I'm adding the exponents because I'm multiplying those two rather. Okay, now I'm getting there. Remember, I am working towards H. I want to isolate H by itself. So it's to my advantage to get rid of this. So this is plus this unit, so I'm going to subtract that unit from each side to get that over there. So I have S squared minus pi squared R squared equals what's left, which is pi squared R squared H squared. Again, since I'm isolating for H, I'm going to flip these two things around. So I have pi squared R squared H squared equals S squared minus pi squared R to the fourth. Now I want H alone. So I'm going to first get rid of pi squared R squared by dividing through on both sides. So I'm left with H squared over here equals all of this over pi squared R squared. Nothing more I can do here. because s squared minus this unit is a little bit different than just having this unit. It's very close, but they're different. Now I still have that squared thing, so now I'm going to take the square root of each of those. So if I take the square root of h squared, I'm left with h. So that's how I get my h. Look how easy I'm not going to figure all this out. I'm just going to go plus or minus, because it's going to be the positive or negative of the square root of this whole big long thing. S squared minus pi squared r to the fourth over pi squared r to the second. Again, why you would need to do all that, sometimes it just makes it work out a little bit easier if it's set up a little more straightforward. But often we would do like we did in part A and just plug in numbers and try it from there. Okay, as always, stop, rewind, pause as often as you need to. Your assignment for today then is page 124, numbers 1, 2, 3, and 4. There you go. Do good math. Ask questions if you have any.